Hello friends, welcome to this new video. In this video, we will learn how to convert an NFA to DFA. So first, we have to know what is NFA. NFA is a 5-tuple finite automata which is non-deterministic. It is also known as non-deterministic finite automata. So what are these 5 tuples? You can see transition function, state of set of input, initial state, final state, and set of state. So let us take an example in order to understand it. So first we have a NFA which is non-deterministic. What it does non-deterministic means? It means that in each and every step doesn't have an input properly. Like here we have 0 as an input and we have output as q0, and we have also for same input we have another state, we have transition from another state. So this is known as NFA non-deterministic finite automata. So in order to convert it to DFA, first we have to make a successor table. So what is a successor table? It is a table consisting of states according to their inputs. So here we have q0, and we can see in the diagram when q0 is given input 0, it goes to q0 as well as q1. You can see in the figure. That's why we have here q0 and q1. And when we have q0 and input as 1, we have the state q0. So here we have q0. Similarly, we have created, we have derived what is the value of q0 q1 at 0. How we have derived it, you can see it here. Like q0 q1, when given input 0, transition q0 0 union q1 0, q0 and 0, what we will get? q0 q1 q0 q1. And when we have q1 and 0, so here we doesn't have any transition from q1. That's why we have a null value, that is 5. So the union of both of these, we will get q0 q1. So that's why we have put it, write it q0 q1. After that, what is the value of q0 q1 at when we give input as 1? You can see it here. Similarly, we have transition from q0 to q1 and q1 to 1. So when we have q0 and 1, we have q0 and 1, we have q0. And when q1 and 1, there is no transition for q1 to 1. That's why we have null value. So here union of both of these, we will get q0. So we will put the value of here q0. So this is our successor table, and using this successor table we will create an automata which is deterministic. So as per the successor table, we have two states, q0 and q0 q1. So we'll draw q0 and q0 q1 as two states. As in the figure of NFA, we have q1 two states, initial and final. So we will consider q0 q1 as its final state. So here we will construct a transition table, a transition diagram, state diagram. So here, as per the table, when we will give input on q0 1, then it will go to q0, and when input given as 0, it give to q0 q1. When q0 q1 has input 0, it is in the same state. That's why a self loop. After that, when q0 q1 has input 1, it goes to q0, that is initial state. So this is an example of how to convert an non-deterministic finite automata to deterministic finite automata. Okay friends, I hope you will get it. Let us take another example. So here, as per the previous question, we have similar NFA, and we will construct a successor table according to previous question. We have a successor table in which we will give input 0 and 1. when we will give input 0, it gives q0 q1, and when give input 1, there is no transition for that. That's why we have written it phi. When there is no transition for any state, we will put as a phi q0 q1. And how we will get the state of q0 q1 when input is 0? We will use the transition q0 0, then q1 0, both union. q1 0 is phi and q0 q1, so we will get q0 q1 here. Similarly, q0 q1 when given input as 1, we will write it q0 q1 union q1 1. So both of these does not have a transition for 1, so both of them are phi, and union of both phi are phi. So this is our successor table, and we will use this successor table in order to make a deterministic finite automata. Here we have three states, we will say q0 q0 q1 and phi. So we have three states, and we will give input as per the successor table and create it. Like when q0 have 0, it goes to q0 q1. q0 q1 when we will give 0, it goes to same state q0 q1. And when given input as 1, it goes to a null state, that is phi. We have created a null state phi. And when q0 have 1 as input, it goes to phi. And when phi state has 0 and 1 input, it goes to similar state. So this is the second problem that we have discussed. So we have discussed two problems in this video. I hope you will get it, friends. Thank you for watching the video. Please like, subscribe and comment. Thank you, friends.